reminder, I'll have the lecture channel open during lecture. If you have questions, you can ask there, or the old-fashioned raise your hand. That might be one of the last times I remind you of that. It's been 2 weeks. So we didn't quite get through array lists and hash map last time, so today's our design catch-up day. So let's get caught up. I'm going to back up a little bit. We kind of rushed a few things. I just mentioned a couple things about array lists when we first got to it, but I didn't do it any justice at all. So let's start at the top from array lists and talk about what these things are. So array lists are our sequential data structure, meaning the order matters, and we have values stored at indices starting at 0 and going up to the length of the array list -1. No matter what language you're coming from, you've seen these things. These are our lists in Python, our arrays in JavaScript, our vectors in C++. This is just our standard first data structure, I guess. Sequential index starting at 0. So this is our first type that we have to import in Java. So anytime we use a class in Java, array list being a class, and we're going to start introducing a few more kind of vocab terms, class and object today. Array list is a class, so we need to import it. Now the array list class has to live in a file called arraylist.java. Java is not above its own naming convention. And it lives in a package named java.util. So we know that somewhere in Java source code there is a directory named Java with a subdirectory named util with a file named arraylist.java where all the ArrayList class code lives. So we have to import that if we want to use it. There are a few classes that don't need to be imported. We have string that we've already been using. We have system. We have integer that we're about to see for the first time today. We have our primitive types, which are types that start with lowercase letters. Int is the only example on the slide right now. Bless you. So there are some types that don't need to be imported. These are so fundamental to programming that Java developers, they said, you know what, we're going to import those ones for you. So we don't have to import any of those. ArrayList is the first one that's not auto-imported that we're going to use in this class. HashMap will be the second. So we do need to import java.util.ArrayList, but this is kind of less important these days than it used to be in the past because IntelliJ, you start typing ArrayList of integer and type out this line, it's going to say, let me import that for you. I see what you're doing here. And it'll just add this line in most cases. It depends exactly how you type it. Sometimes it misses it. But it'll usually auto-import this for you. We used to have to remember our imports and get really crazy error messages. Now it auto-imports, and if it doesn't, it'll give you a red squiggle and say, you want me to import that thing for you? So a little bit easier these days, meaning we can save our brain power for bigger and better things. But for what it's worth, that does have to be there. When we want to create an array list, so array list is a class, what we need to do is create an object of that class, or an object of type array list, or instantiate the array list class. There's a lot of different ways of saying it. We're going to talk about that more in depth on week 4 when we talk about classes and objects proper and constructors and all that stuff. But there are a few terms that I'm going to throw out there today because we really need to start talking about classes and objects because Java is built from the ground up with objects and classes in mind. It's an object-oriented programming language, so we do have to talk about some of it right now. So let's talk about this line. We're going to use the keyword new to create a new array list. This is going to give us an empty array list on this line. New is our keyword that says we need a new object of this type. We're going to specify the type of the object. We're going to have these angle brackets, which is where a type parameter would go, which I'll talk about a little more when we get to this part over here. And then an empty parameter, an empty argument list. So what new does is calls a special method called a constructor. And since that is a method call, we do need an argument list, even though it's empty. So we have an empty argument list, but we still need our parentheses, just like any other method call, just like any other function call. We need our argument list, even though it's empty here. The constructor is always named the same as the name of the class. And then I already said I'm going to defer this to another slide. So this is what we're going to do to create a new array list. We took this for granted in Python when we would just say open square bracket, close square bracket, and bam, we got a new list. Didn't have to think about it too much. Java's going to make us be a bit more explicit. So new array list, and then 2 empty parameter lists. Oh, the slide says week 3, but it's week 4. I restructured things a little bit. Week 3 is going to be all about testing and recursion. So when we create a variable that's going to store an array list, when we create a variable of type array list, we don't just say, give me a variable of type array list. I'll explain what those quotes meant in a minute, by the way. When we create a variable of type array list, we don't just say, give me a variable of type array list. We have to specify one other thing. We know Java is strongly typed, that every variable needs a type, so this variable needs to be of type array list. But Java takes that one step further when it comes to data structures and says, you need a data structure and a type parameter, which is the type that this data structure is going to store. So we don't just create an array list, we're creating an array list of integers, which means that this array list can only ever store integers. So we have to specify a type, and we have to stick to that type. So this array list can't store a string. If we try to add a string to this array list, we're going to be in trouble. Java's going to complain and not run our code. Not going to happen. This can only ever store integers because we're specifying that it's an array list of integers. Yes?
You have different types of array lists, like integers and strings?
Nope. So you have to stick with the type in the type parent. Well, kind of. I'll give a little asterisk on that one. So once you specify the type, you can only store variables of values of that type. There are ways we can mix types. That's a conversation for much later in the course, polymorphism. We're going to see ways that we can somewhat bend that rule a little bit. And if you want to get, not fancy, if you want to get impractical, I'll say, with it, you can create an array list of object, which could store any type in it, but it's not a very useful thing to do in most cases. So we're going to store only integers in this, and notice that I have this type. Oh, I forgot in the last lecture, I remember now, to come back to this one. So this is also our type parameter list. So here I specified that this is an array list of integer. Here I didn't. I just said array list of angle brackets. You can put integer here. It kind of should be. It's kind of supposed to be there. It does intend to be array list of integer in that type parameter list also. But this is one case where Java does let us use a little bit of shorthand. So since Java sees that we're creating an array list and storing it in a variable of type array list of integer, it's going to infer that we mean integer here. Now you can optionally type integer here, but if Java's going to let us get away with it, let's save ourselves a few keystrokes and not put integer there. In fact, if you do type integer there, the code's going to run. Everything's going to be just as it is in this example. But IntelliJ will say, hey, you know you didn't have to type that. Maybe delete that. You don't need that there. It'll do that by graying it out. And I think it even gives you a warning. Like it comes up with a pop-up and says, hey, you can get rid of this. So we leave it empty on the right-hand side. If we're not assigning this new array list to a variable, that's where we would specify the type, if it can't be inferred by Java. Can you compare an array list to another? Yes. You sure can. I'll have a longer conversation about that next week when we talk about testing. How do you test the method that returns an array list? You can use dot equals. If I say R1 dot equals R2, that will compare all the elements in both array lists and check if they're the same at every single index. And if they are, it'll resolve to true. If not, it'll resolve to false. So yes, we can. It will come up on a homework assignment. I forget if it's task 2 or task 3, but I make sure that you actually have to do that manually and iterate through the array lists and check all the values to make sure that they're the same. Maybe task 4, I forget. It's when we do movies with lists of actors. I forget when that comes up. So notice that I'm using a capital I integer and not int when I specify my type parameter. This is because type parameters can only be classes. So I slipped a few times earlier in the semester and I used the word primitive. I didn't mean to do that, but oops. Because today, this is where I want to introduce primitive and talk about it. Before, I just didn't want to have the conversation earlier because there's too much stuff to cram into the first week and a half. But primitive types are any of our types that start with lowercase letters. Our int, double, boolean are the three that we've seen. And those are what we call primitive types, and they behave differently than what I'll call class types, which are any type that starts with an uppercase letter. Integer, array list, string, which we're pretending strings are primitives when we do our memory diagrams, but they are class types, which means instances of them will be objects. Again, we'll have much longer conversations about objects and classes in week 4. But anything with a capital letter is our class type. Type parameters have to be class types. We don't have a choice. Have to be class types. So we're going to use this capital I integer, which is the class equivalent of the primitive type int. We have these for double and boolean. Lowercase d double is the primitive type. Capital D double is the class type. Same thing with boolean. Lowercase b, uppercase b, primitive versus class type. So if we want to create a data structure that stores these primitive values, we use the class equivalent. And the good news is that in most cases, Java is going to automatically convert between these using something called auto-boxing. So right here, when I'm trying to put a lowercase I int into an uppercase I integer data structure, Java is just going to convert that to the class type for me. And when I want to get a value, I have out, which is of type lowercase I int. This is a primitive type, and I'm getting a capital I integer out of this array list. It's going to say, yeah, I'll convert that back to the primitive for you. It's going to automatically do those conversions, so it's not something we have to think about too often. This will come up sometimes. In most cases, Java is just going to handle it for us. But if you submit on the homework, one thing where we always have trouble with this course is if the return type is wrong and you submit to AutoLab, it's going to complain about that. So in the homework, if I say return an int and your method returns a capital I integer, it's going to cause issues in AutoLab. I'll print out the error message and it'll say expected int got integer, type mismatch, everything's broken. And when you see that in AutoLab, we can kind of figure out where the issue is. But in general, to avoid that, in this course, and this is kind of the way I just code anyway, in this course, I'll always use the primitive types unless I have to use the class types. So I only ever have to use the class types when they're type parameters for data structures. That's the only time I'm ever going to use capital I integer, at least on the homework assignments. That's the only time I'm going to use them, when I absolutely need to. All other cases, if it's your parameters, if it's your return types on the homework, it should always be the primitive types. This will come up. It always comes up. Please don't be someone who does this. But it comes up. I mean, if you are, that's fine too. But it's easy to make mistakes. But if the homework says return a value of type int, and a lot of students do, surprising number of them do, will return type integer, which I don't quite understand. If you do this and you have a reason of why you did it that's reasonable, I'd love to hear it. But if you're reading the assignment, it says return a value of type int, and instead you go to IntelliJ, you hold shift, you type capital I, and then spell out all of integer. Where that disconnect is, I don't know, but a surprising number of students do it. I have my suspicions. I think it's when a student doesn't write their own code for various reasons. But I don't want to, what am I saying? I don't have any evidence of that. But that's what I suspect, because whenever I confront them and I'm like, why did you do that? It says int. Why did you type? You did so much extra work. And they never give me an answer at all. So if you can't even answer that question, I gotta be suspicious. But anyway, don't be one of those people. It'll always be int. So just don't type integer unless it's a type parameter. And then you won't have that issue in AutoLab. Because that wastes the student's time, by the way. That's one of the worst parts about it. you'll spend hours trying to figure out what that issue is, which is why I want to know why anyone does that, so I can update my wording on it and whatever I got to do to avoid that from happening. Because you can spend hours trying to figure out, oh, I used integer instead of int, because it's a stupid thing. It doesn't reflect your understanding of programming. Yep.
So, when you declare a variable that's just int like int,
Mm-hmm.
it goes on the heap memory, right?
If it's the lowercase I int, it'll go on the stack.
So if you declare it as like int as your class, then would it go on the heap?
I should have looked this up between lectures. I got this question in the previous lecture, and I don't know 100%, but I believe it goes on the heap when it's a capital I integer.
Like instead of calling the class types, do we call the reference types? Because it's going to its object.
It's related to references. Yeah, it'll be stored as a reference, and then I just call them class types. I don't know. That's just what I call them. But yeah, they behave with references. I'm pretty sure the autobox values do go on the heap and then stored as a reference on the stack. On our memory diagrams, we're not going to do that if that's what you're asking. On your memory diagrams, even if it's a capital I integer, treat it as a primitive. It's the same way we do with strings. That's actually, I never even thought of that for the memory diagrams. They probably should be going on the heap, but for the same reason for strings, I'm putting them on the stack anyway. But I think technically they do get stored in the heap. Unless the compiler does some fancy optimizations, they should be on the heap. Okay. Yeah, that's all I want to say about that. All right, and then finally using an array list. So we created an array list. We talked about type parameters. Once we actually want to use it, pretty straightforward, pretty simple. The one big thing here is we cannot use our square bracket and then our index in the square brackets. We cannot use that notation in Java. We have to call methods. Java doesn't allow that special notation for array lists. It is an object. We can only call methods on them. So we're going to call the add method, which is going to add a value to the next available index. So an empty array list, this will be stored at index 0. An array list with one value in it will be stored at index 1. And then get to get a value at a specific index. Give me the value at index 0. I would say .get of 0. I can't do rn and then bracket 0 bracket. Can't do that. Yep. Right here? Yes. But I didn't introduce those yet. When we do hash maps, I'll introduce those. So this was the lecture question on Wednesday, but I didn't quite get to this. I rushed it right at the end and stuff, and then a lot of students got it wrong. So even if you got Wednesday's question wrong, I did give you credit for that still. So, but this is the point that I was making. Through that lecture question, now we actually have the background and the content to answer that question. So I didn't want to take anybody's points away for that because it wasn't really fair. Memory diagram. What's always fair is memory diagrams. Bless you. The length of an array is dot size, and R2 equals R1. It assigns R2. We're going to see that in the memory diagram, but since it's asked, I want to answer the question. It's going to assign R2 to the reference that's stored in R1, so they'll be referring to the same array list. It will not copy the array list. Okay, so our memory diagram starts off just like any other memory diagram, but oh my goodness, right from line 1, we got a lot of different stuff going on, and this is our first usage of the heap. So when we create a new array list, whenever we see the keyword new, it should tip you off that something's going on in the heap. We're creating an object. That means we're asking the operating system for memory that's going to be anywhere, somewhere on our RAM sticks. It's going to give us that memory to store our array list and then tell us where that memory is. So in our memory diagram, we're going to draw our array list, which is going to be kind of like a mini stack where we're going to have two columns, one for the indices and one for the values at those indices, kind of like name and value. We're going to have indice and value at that indice. And then we're also going to say where this is in memory. So when the operating system gets a chunk of RAM and says, this is yours, It's going to tell us the memory address of the first location in memory that it allocated to us. And we're going to specify that on our memory diagram as a reference like this. I'm going to say OX200 in this example. The number is completely made up. So when we actually run this on our computer, our operating system is going to go to memory. It's going to choose a location and actually have a number, which, remember, memory is one giant array. So it's going to give us the index in that array, which we'll call a memory address. That's the index in memory. And it's going to tell us, here's where you can find your first byte of data, of memory that I allocated to you. These are going to be hex values. So we specify these with OX. OX means it'll be a hex value. And then any number you choose for your memory diagram. When you're doing your memory diagram, you don't have an operating system sitting there actually allocating memory and deciding what memory address you actually get. So to represent our memory addresses in our memory diagrams, OX, and then choose a random number. When I made this slide, I was feeling the number 200 for some reason. So I wrote 200 when I made this slide. You can put any number you want here. It doesn't have to be 3 digits. A lot of students just do OX1, OX2, OX3. And if you should have the OX to indicate that it's a hex value. Memory addresses are hex values. But guess what happens if you forget your OX? Nothing. I don't care. If you don't have OX, that will never be the make or break decision when we're grading your quizzes. If you just have 1, 2, 3 for your references for your objects, I don't care. As long as you have something that indicates the location in memory for that object. I'm always going to do OX in the slides because I want to always remember that those are memory addresses. And then what's stored on the stack. When I have a variable of type, yes, any number. I've seen all the numbers that you're thinking of right now. They all show up on quizzes. So the number after OX is the index, yes. Yeah, the index in the memory array. And we'll see these when we run the debugger. We'll see this information. We'll actually be able to see those numbers, or at least numbers that kind of represent the same thing. Everything's very obfuscated by the JVM, so we don't actually get to see those memory addresses, but we kind of get to see things that mean the same thing, and we'll see those. We'll see those in IntelliJ. Hopefully at the end of this lecture. I got there in the previous lecture. So what's actually stored in our variable, when we have a variable type array list in this case, of any class type, is not the object itself. R1 does not store an array list, which may seem like a subtle distinction, but it's a very important distinction. R1 stores a reference to an array list. That reference is the memory address of where we can find that array list in memory. We can think of these as instructions. This is like a map. I think of these as maps. Like R1 has a map that tells me how do I navigate memory and find this array list that it's referring to. And this map says you can find it at address OX200. We follow the map and we can find this object on the heap. That's the only thing that R1 stores, is the directions of where to find the array list on the heap. It does not store anything else. This object of type array list does not store an array list. Okay, so let's get a few things in our array list before we talk about more kind of the implications of that reference. We're going to have our loop, our for loop. We have x that's going to be declared as part of that loop. We're going to go through and call the add method. Add is going to add a value at the next available index. This array list is empty when we add 10 minus 0, which is 10. So we're going to add 10 at index 0. And we can see the structure of our array list in memory. Once we add all these values, we're going to get our values at the indices 0 through 3, the values 10 through 7. And when we print out an array list, for what it's worth, this is the notation we get. Square brackets, comma separated values. If you don't remember that format, that's another thing that's not going to be make or break. And when I say that, these things won't be make or break. If this were percentage-based grading, each one of those would be like -2, -3. So it's pass or fail. These aren't going to be pass-fail decisions. If you have the format wrong here, you forget to cross out your stack frame, but you have the reference and all the values in the array list correct, that would be, if this were the quiz, the entire quiz, that would be what I was testing. You'd still get a pass on that one. Percentage-based grading, I'd had this whole rubric that says if you didn't cross out your code block, -2. If you didn't have this exact format, and I don't like doing any of that, so I don't. So we print it out, that's what we get. And then our first implication of references. Why would I care if R1 stores an array list or a reference to an array list? It's a subtle difference. Here's where it starts mattering, is when I have a new variable of type array list, which will also not store an array list, and I assign it the value of R1. Whenever I have an assignment, what happens is the machine is going to look up the value for the right-hand side in the stack, find that variable, and it's going to look at what that variable is storing, which is whatever's sitting right next to it in the stack in the memory diagram, which is a reference, not an array list. It's a reference. So whatever is sitting right here next to the variable name, that's what's assigned to the variable in the left-hand side of the assignment operator. So R2 does not get a copy of the array list. We don't have two array lists. We have one array list at memory address OX200 and two variables that refer to the same array list. So R1 and R2 both refer to the same array list. They store the same value. And we can access that array list through either one of the variables. We won't see it in this example quite yet. We'll start seeing it later in the semester. But if I modify that array list through either R1 or R2, it's going to affect both of them. And yes, this is not, I'll call this assigned by reference. This is assigned by reference. No, it's not technically assigned by reference. For those of you who want to call me out, I'll call myself out before you get a chance to. It's not technically assigned by reference. It's assigned by value, but in Java for object types, the value is a reference. So, but I'll call this assigned by reference incorrectly. I know, I'm sorry, not that sorry, because assigned by reference and eventually passed by reference that we're going to see, it's just a lot fewer syllables than assigned by value, but the value happens to be a reference. I don't feel like saying that every time. I'm sorry. Sorry, not sorry, but I'm going to call this assigned by reference. There is a subtle difference between the two that will be important in CSE 220. Your 220 instructor can badmouth me and tell me how stupid I am for calling this assigned by reference and how I'm completely wrong and everything. They'll straighten you out next semester. This semester, we're going to call this assigned by reference. When you do see this in C in 220, this will be effectively the same as pointers. This is the only thing Java has effectively are pointers in C and C++ and doesn't have references and assigned by reference and passed by reference. So it's like passing a pointer, if that makes any sense to you. Or when you get to 220 and you hear about pointers, the pointer stuff is the only way Java works. And then we print R2. It's the same exact, it's a reference to the same exact thing. We're going to get the same exact thing here. And then there's kind of one problem, I guess. Not really problem, but this right here, my issue, I'll have a personal issue with it instead of calling it a problem, is you would never do this. There's never a reason to actually do this. Why would you want two variables that refer to the same object in the same stack frame? I can already, if I want to access that object, I'll access it through R1. Like, there's not really a reason to do this. Why would I want two variables for the same thing? I don't. But I want to show you how that works in a lecture example, because we're about to see it right here when we call a method that we're going to have the same effect. Yo.
If you assign R2 to a modified value from like R1 but modified, is it changing R1 too, or is it?
Yeah. Yeah, so like after this assignment, if I change R2 at all, it's also going to change R1 because they're referring to the same object. If I change R1 before the assignment, R2 is going to get that change. Because I'm going over to the heap, I would make that change, and then the previous version of R1 wouldn't exist anymore because it's modified, and then R2 would get that modified version.
But if you assign R2 to like a method called that modifies
If I assign R2 to a method call that modifies R1, yeah, they would both see the modifications. Well, depends the whole structure of that method. So the method would take in R1, modify it, and then return the reference to R1 again, and then reassign that to R2. Is that what you're saying? Okay. So there's one array list on the heap. So any change made to that array list is going to affect both variables or anything that has that reference, OX200. The only way we can have two variables that behave differently, that both refer to an array list, is creating a new array list.
Immutable types.
Yeah, I think you might be thinking of immutable types. Array list is mutable. And if you don't want to think about those words, don't. We used to talk about immutability in 116. It's just a little too early to talk about immutability. You'll talk about it in probably 305 is where that conversation will go. CSE 305. So we wouldn't ever do this, but we will do it here. So we have the same thing here, but when it's split across a method call, and now we're split across stack frames, this is where things get more important. So we have the same thing, array list of integer rn equals r1, our parameter equal to our argument. It's the same thing as here. I'm creating a variable and assigning it the value at r1, which is a reference, but I'm doing it across a method call, which is something we'll do often. It's a very useful thing to do. We'll see this all the time. And now rn also has that reference OX200. It's still referring to the same object that R1 and R2 are referring to. So in our stack frame, we have that reference, which is passed by reference. Yes, it's passed by value, but the value happens to be a reference. I'm going to call it passed by reference just to cut down the amount of air I have to breathe to say all this stuff. So I'm going to say passed by reference a lot. We're going to put our variable inside the stack. We've seen stack frames, method calls before. So I'm going to gloss over some of those details, unless there are questions. I see people who are not in the class are having some conversations, so I'm trying to ignore them. I assume they're just explaining things. We're going to get into this loop. Size is going to be the length of this array list. So we'll check the length of the array list, which is 4. So x less than 4, x plus plus, x starts at 0. This is a method call, but I want to wait until right here. I'll talk about a method call. And then out plus equals rn.get. This little guy right here, let's talk about what this is. The dot operator. You've used this a lot. No matter what language you've used before coming into 116, you've used this a lot, the dot operator. But now that we're talking about references in the stack versus the heap, let's talk about what the dot operator actually does. And what it does is follows a reference over to the heap. So rn is a variable that stores a reference, and it's storing the reference OX200, which we don't actually care about. That's just a made-up number that I made for this memory diagram. We don't actually care about the reference itself. We care about the object to which it refers. The dot operator means I know your reference, rn, I know you're storing a reference. Follow that map, follow those directions, and take me over to the heap to where that object is, that object to which you refer. So rn dot means rn, I know you're a reference, follow that reference over to the heap, and now after the dot operator, we are at this object in memory. We followed the map, we followed those directions, we went to that memory address, that reference, that index of memory, and now we're sitting at this array list, and then we call the get method. So we're calling get on this array list OX200, and then getting x, which is 0. So give me the value at index 0, and we get 10. So that's the dot operator, means I know you're a reference, don't care about the reference, take me to your object. Take me to the heap. And we run around the loop a few times. We get out. Don't forget to cross out your stack frames or code blocks. We're going to return out, get 34 back to total, and the method ends. Why does RN have the same reference as other array lists? So RN, so we have array list of integer RN. When we call this method, it's going to be assigned to the argument, which is R1. R1's value is OX200, so that's what R1 resolves to, this reference, and that's what's assigned to Rn. So Rn only gets the reference. We don't create copies of the array list, which is really the important point. We don't create a copy of this array list. Imagine if this array list had 1 billion elements in it. We have a gigabyte of RAM being used up, or it'd actually be more since it's integers. But we have gigabytes of memory being used up by this array list, and we want to call this method and sum up some values. We don't want to make a copy of that and take up several gigs more of memory when we do that. Instead, we're going to say, hey, Rn, this stack frame, this method call, here's where you can go to find those billion elements. Not making a copy of them, but here's the instructions of where you can find it. That's why we want pass by reference. Yeah. Through the method call. So sum is the method here. So we're calling the method. So we're taking the arguments and assigning them to the parameters. Yep.
To input Rn, like as an array, I cannot how in Python I could directly write a list. I cannot do that. At first I would create the whole array list and then say
there is a shorthand where we can create an array list and populate it at the same time. It'll come up in, I think, a lecture next week, but I can at least verbalize it right now. You do a new array list and then do arrays.asList and then comma separated all your values.
Okay.
So you can do it in one line.
So in input we can directly write a list.
Yeah. Yeah, so you can do that all in one line. Makes it a lot easier. Especially for testing, when you're testing the, I forgot the name of the method, but one of the methods in task one. Yeah. Yeah, it's a pain. So I'll definitely mention that before when we talk about unit testing. Hash map. All right, hash maps. These are our key value stores. Whatever language you're coming from, dictionary in Python, object in JavaScript. I believe it's just map in C++. These are, instead of storing values and storing them at indices starting at 0, now we're going to store values at keys, which themselves can be any value and any type. So the order for these does not matter. Like it did in array list, these can be stored in any order. And in fact, the order is going to get mixed up as we insert into these key value stores. You might have noticed that in any other language. You stuff a bunch of values in your key value store, and then you just iterate over them or print them to the screen. They're not always in the same order in which you inserted them. That's going to be true with our hash maps in Java. The order is not preserved. That we can get these in any order. And we can't have duplicate keys. Hopefully they hammered that into your heads in 115. But you can't have duplicate keys. You can't have a key that maps to 2 different values. Can't have it. We have to import it, just like array lists. Got to import it. I don't have much more to add to that. For what it's worth, this is a java.lang package that's auto-imported. Anything in there is auto-imported. That's where our string, system, integer, capital D double, that's where all those live. And the first difference from array list is that we need 2 type parameters. So we don't just create a hash map of integers, a hash map of strings. We need to create a hash map that maps one type to another type, because our keys and values can actually be different types. We don't always have to map integers to integers. Here I have a hash map that maps strings to integers, and I'm going to do that by specifying 2 type parameters. So I have 2 types here. The first one's the type of the keys, the second one's the type of the values. When I want to add a key value pair, I'm going to use the put method, comma separated key value. And then to get the value at a specific key, I'm going to use .get, just like we did with ArrayList.get. Instead of giving it an index, I'm going to give it a key and then give me the value at that key. And then iterating over them, I'm going to use a fancier loop, I guess. This is called the enhanced for loop in Java. I don't like that term. I'm going to call them for each loops because that's what they're called in other languages. But if you ever see enhanced for loop, that's the Java term for these things. These behave just like your loops in Python. This is the loop you used all throughout 115. If you didn't take 115 here, let me give you a quick breakdown. For, same keyword that we used for our what I call regular for loops. Because these days, these are kind of more regular than the other ones. These are more common, and you see these earlier than the other ones now. But that was the first one, like the only one that existed when I was learning this stuff. So I think of those as the regular ones. But anyway, for, and then we were declaring a variable. So we need type, and then variable name, and then a colon, which is read as in, and then a data structure. And this is going to iterate over all the values in this data structure, putting those values into this variable one at a time. So this will iterate over all the keys of this hash map one at a time, putting them in the variable key one at a time, and then printing each one to the screen is the effect of this loop. I think that's all I have to say about these. So if you want to iterate over a data structure without setting up your indices or whatever, we're going to use this for each loop. And so the whole thing, putting it all together, for string key in this hash map's key set. And we have three different ways, I guess, of iterating over all the values of a hash map, kind of overloading the word value there. Either iterating over the keys only or iterating over the values only. And there is a third one. If you want to look up entry set and you want to iterate over both simultaneously, go for it. I never remember the syntax for it, so I chose not to use some brain power to memorize that, and I don't feel like looking it up all the time. So what I do is this third option here is I'm going to iterate over all the keys in the map, and in the first line of my loop, I'm going to access the value at that key. This is easier for me to remember. So I'm going to iterate over the keys. I get every key, and I'm going to use my get on that key to get its value, and now I have a loop where I have access to both the keys and values, so I can iterate over each key value pair. So usually I'll set up this loop, even if I don't need keys and values. I'm going to type out those first two lines. That gives me time to think about what I'm going to type in that loop itself. I don't know. It's just the way I like to code. If you want to look up entry set, I'm not going to stop you. It's perfectly valid. Let's see it in a memory diagram. All right, so this starts off just like our array list example. We're going to have a variable that stores a reference to a hash map. The structure of our hash map is going to be the same, this kind of mini stack, except instead of indices, we have the keys and the values over here. We're going to put some values, key value pairs in our hash map. We're going to print some things to the screen. And I don't have too much to say about a few of these lines, but when we get to this one, remember the order of your hash map doesn't matter. When I run this code, I do get digs before Alan, even though I added Alan first. So the order can be different, and it's my job when I'm writing the quizzes to make sure the order doesn't matter, or else we're going to get all kinds of contradictory results in our memory diagrams. So I'll make sure the order doesn't matter. When you loop over your values, your key value pairs in your hash maps, you can choose whatever order you want to iterate over them in. I'm not going to care what the order is, and I'm going to make sure it's not going to change the end result of your memory diagrams. Yeah. They're sorted, but they're sorted by the hash values of the keys, which isn't something we can predict. So I could give you the hash function and make you go through all this extra work to determine, because it is a deterministic order. I could do that, but it'd be really painful. And it's really not something that we want to focus a lot of energy on in 116. We got other things. There's a lot of stuff to worry about in this course, so I try to trim some things like that. But it's not just sorted. I mean, it's not, Diggs came before Alan when I actually ran this code. It's not sorted like alphabetically, for example. What do you mean? Like I added Alan first and then Diggs, but I get Diggs and then Alan. You know what I mean? Or am I missing what you're saying? They're not. It's not in this example. Like I actually ran this code and got D before A. They're sorted by the hash value of the key. So it is sorted, but it's not in a way that we can reasonably predict without running the code. What's it?
You're saying lexicographically?
No, it's not lexicographically is what I'm saying. It's by its hash function, which is something that it's more complex than I know. I don't know it off the top of my head. But it's some hash function. You can go into the string class and look at its hash function. It's going to be some blob of math. It's not super interesting. Well, it's super interesting if you're into that stuff, I guess.
Is there a function that can sort it in other ways?
We can sort it, but not by default in a hash map. We can use, I think, a tree map and then give it a sorting, a comparator, and then it'll sort lexicographically. But the hash map won't do that. So possibly you used the tree map before. That might have been where you're getting that from. But hash map won't do that. Okay, so any order you want to iterate over them in, I assume most of you will just iterate over them in the order in which they were inserted. That's what I'm going to do right here. We're going to iterate over the keys in the key set. I'm going to go in the order in which they were inserted. Don't forget to cross out your value and go to the next one. So this iterates over the key set. Key is going to be one of the keys, then the other. Values, same thing, but just for the values. And then my favorite, we're going to iterate over the keys, but access the values. So now I have both key and value. And notice that since key and value, these are part of the code blocks that are no longer in memory at this point, we are allowed to reuse those variable names and not do key 2, value 2. We don't have to do any mess like that. Then cross out that one. We hit the end of the program. I want to really quickly. So in this example, we can run this and see it in action. But I want to show very quickly, if we click next to the line number in IntelliJ and get this red circle, this is a breakpoint, and then run our program in the debugger, what we get is the program will stop, and then I can step through my program one line at a time and watch everything that's happening. And I can see all of the stack frames at this point, right after the sum method call. I can see the sum stack frame and the main stack frame. And if I click on them, I can see all the values of the variables inside that stack frame. And some of the variables are going to have this at and then some random number. That means that this is a reference to an object on the heap. And I can click this arrow to see all of the values. I can see R2,